Dear students, good morning. So in this lecture, we are going to discuss about unguided media. So guided media we have discussed in the previous lecture. In unguided media, it is classified into different categories. We will discuss in this lecture. Dear students, in Unit 1, classroom discussion topic 7, that is unguided media. This unguided media we will discuss in this lecture. So before starting this lecture, we must know that the lecture outcomes. After listening to this video lecture, you will understand the unguided media and real-time usages of it. Okay, so what are the unguided medias are there and what is the real-time usage of it? So the transmission medium, already we know that it's classified into guided media and unguided media. The unguided media means wireless network we are saying. There the free spaces are acting as the medium. Okay. So what is unguided media? Unguided media means the unguided media transport electromagnetic waves without using a physical conductor. So in the wired medium, we have the physical conductors are there for transmit the electromagnetic signals. But in the unguided media, there is no conductor will be used for transmit the signals. This type of communication is often referred to as wireless communication, where we are not using conductor, physical conductor, and transmit the signals. That is considered as the wireless network. For that, we have three waves are there for transmit the signals in the free space: radio waves, microwaves, and infrared. Signals are normally broadcast through free space and thus are available to anyone who has a device capable of receiving them. Okay, these waves are transmitted in the air. Those who are available receivers, they can receive those signals. So this is the diagrammatic representation of the frequency of the signals which used in the particular band. Okay, so see here 3 kilohertz to 300 kilohertz signal, gigahertz signals considered as the radio wave or microwave. Okay, so these range of signals are considered as radio wave or microwave. And 300 gigahertz to 400 terahertz, these signals are considered as the infrared signals. And above 400 terahertz is considered as the light wave. Okay. In unguided media, that unguided signals can travel from the source to destination in several ways. How it is transmitted? Okay. Ground propagation, sky propagation, line of sight propagation. Okay. So what is ground propagation? You see here. Okay, this is the ionosphere. It is there. There, the antenna is there. It is hugging the over the earth. It is considered as the ground propagation. What is the ranges is below 2 megahertz. The range of the signal is 2 megahertz. The below than 2 megahertz. 2 to 30 megahertz, we can say that it is a sky propagation. Then above 30 megahertz, we can say that line of sight propagation. Okay. The ground propagation, what will be happen? The radio waves travel through the lowest portion of the atmosphere. That means hugging the earth. Okay. These low frequency signals emanate in all directions from the transmitting antenna and flow the curvature of the planet. Okay. So the previous diagram is seen here. This is the earth is there. Okay, so it is covering the earth. So hugging, it's like hugging the earth. The surface of the earth, the signals are transmitted. Okay. So distance depends on the amount of power in the signal. that power, the greater the power, the greater the distance. How much power is more, accordingly it will reach the distance. In sky propagation, higher frequency radio waves radiate upward into the ionosphere. Okay. So here, what happened? Upwards, not towards the earth. It is upwards towards the ionosphere. Okay, the pink color is saying that ionosphere. The signal is reached to upwards ionosphere and reached to another tower. Okay, so this is the sky propagation. This type of transmission allows for greater distance with lower output power. If power is low, even it will reach the greater distance. Here, power should be more, then only it will reach greater distance. If power is less, very less distance. Here, even the less power, it will produce more distance. Okay. The last one is line of sight propagation. Here, it will be used for very high frequency signals are transmitted in straight lines. Okay, directly from antenna to antenna. So antenna must be directional. Directional antenna we have to use facing each other and either tall enough or close enough together not to be affected by the curvature of the earth. Okay. So it is the line of sight we are using. It is not affect the curvature of the earth. Okay. It is directly connected to antenna connection. So line of sight propagation is tricky because radio transmission cannot be completely focused. Okay. So as per the diagram, we have three propagation method is there: ground propagation, sky propagation, and line of sight propagation. So according to the frequency, it will be classified into different ranges. Okay, so these waves are split into 8 ranges. Okay, so these 8 ranges are called like band. Okay, what are the bands it is used? So these bands are rated from very low frequency to extremely high frequency. Okay, so how it is there? 3 to 30 kilohertz, very low frequency. 30 to 300 kilohertz, low frequency. 300 kilohertz to 300 megahertz. What propagation they are using? That is also given. Ground propagation. These two, because already we have discussed less than 300 kilohertz of signal may be propagated in ground propagation. Okay. So, and middle frequency is 300 to 3 megahertz, and high frequency means 3 to 330 megahertz. 3 to 30 megahertz, and very high frequency. What happened? Very high frequency means 30 to 300 megahertz. So these three signals are used in sky propagation. Okay. So here will be fast AM radio signals. Where it is used, that applications of the signals also mentioned here. Okay. In AM radio, we are using 300 kilohertz to 3 megahertz. Okay. In 3 to 30 megahertz used in citizen band, ship and aircraft communications. They are using for this 3 to 30 megahertz. Finally, these three are line of sight communications. 30 megahertz to 3 gigahertz for ultra high frequency. 3 to 30 gigahertz are super high frequency, and 30 to 300 gigahertz are extremely high frequency. Where radar or satellite communication, they are using these signals. Okay, 30 to 300 gigahertz. Or satellite communication, they are using for 3 to 30 gigahertz. It's also used as line of sight. So in wireless transmission, we are using three waves: radio waves, microwaves, and infrared. Radio waves means radio waves are used for multicast communication such as radio and television for paging systems. They can penetrate through the walls, highly regulated, and use omnidirectional antennas. Okay, so the radio waves are using omnidirectional antenna. What is omnidirectional antenna? Radio waves use omnidirectional antenna that send out signals in all the directions. Okay, so it will send the signals to in all directions. So based on this wavelength and strength, the purpose of transmission, we can have several types of antennas. Above figure, this figure is showing this omnidirectional antenna. What is the applications of omnidirectional antenna? Omnidirectional characteristics of radio waves make them useful for multicasting, in which there is one sender but many receivers. So what is the example for omnidirectional? AM and FM radio, television, broadcasting, maritime radio, cordless phones, and paging. These are the examples of multicasting. So now microwaves. Microwaves are used for unicast communication, okay, such as cellular telephone, satellite networks, and wireless local area network. Higher frequency ranges we are used. Okay, so these higher frequency range of signals cannot penetrate the walls. So use directional antennas for point-to-point line of sight communications. Okay, so see here, the waves are how it is. It's a high frequency. Okay, this is the high frequency. Is that radio waves? Compared with this is the high frequency. Again, microwaves. Then after that microwaves, we can say ultraviolet lights. Then finally gamma rays we are saying. So, which is the visible lights? So these ranges 10 power 14 to 10 power in between 10 power 15. These ranges of lights are visible lights. Okay. So this is the unidirectional antenna. This focus may be in opposite direction, that is the dish antenna. So nowadays we are not using this. Even we are using the television dish. No, this antenna used like this. And a horn antenna. This horn antenna is it's look like a horn. That's why it's showing that the horn antenna. You will get the wave from this side and it will be reflected from here to multicasting. Okay. So finally, infrared signal. Infrared signal can be used for short range communication in a closed area using line of sight propagation. So nowadays in mobile there is no infrared. Previously, when the mobile phones are came, there is infrared waves are there. You will keep the phone like this. So here this line of sight will be created here. Then we can transmit the data using the infrared signals. The infrared band almost to 4000 terahertz has excellent potential for data transmission. Such a wide bandwidth can be used to transmit digital data with very high data rate. Okay, so 400 terahertz means you think how much high power. So there is Infrared Data Association (IRDA). So this is one of the association. This association for sponsoring the use of infrared waves has established standards for using these signals for communication between the devices such as keyboards, mics, personal computers, and printers. It's how it will. This association is assigned and make the standards for the communications of infrared signals. Okay, and finally wireless channels. So are the subject to lot more errors than guided media channels. That means we are using the free spaces as medium for wireless transmission. Inferences is one cause for errors can be circumvented with high SNR. So we know that the signals to noise ratio, SNR means signals to noise ratio. So due to this signals to noise ratio, there is more inferences are there. Because of inferences, more SNR will be there. The higher the SNR, the less capacity is available for transmission due to the broadcast nature of the channel. Channel also subject to padding and no coverage ports. So now in this lecture we have discussed about what is unguided media, what are the waves used in the unguided media, and radio waves, microwaves, and infrared waves, how it is classified, what is the applications and usage of it, and what are the directional antenna and omnidirectional antenna used in these wave propagations. So those things we have discussed in this lecture. Okay. So now you will understand this unguided media and real-time usage of it. Okay. So simple questions I given here for your understanding. What is omnidirectional antenna? What is CAT3 token registered per cables in guided media? So what are the BNC key connector used for guided media? In transmission media, which transmission media used in the network? So these are the questions for understanding purpose I kept here. So we will discuss circuit switch techniques in next classroom discussion video lecture. Thank you very much for listening. If any doubt, you can ask me in classroom discussion. Thank you very much.